Chapter 5 is fault interpretation. There are two ways to interpret fault indicators. Classical interpretation, by drawing each fault segments inside the interpretation. You go through this step by manually drawing the interpretation. And modeling fault directly in seismic in 3D. We use both to get a better quality of our faults in the area. But before going to the fault interpretation, we need to generate attribute cubes, which will help us identifying the fault places, as it will show the cube, the last cube will show as an anti-tracking. Anti-tracking will show the discontinuities in our area, which by seeing this discontinuity, we'll know this place is for faults. First step in structural attribute cubes, we need to generate structural smoothing. Smoothing is the smoothing of the input signal is guided to local structure to increase the quantity of seismic reflectors. This is to help to smooth the original seismic cube and to show make the signals more clear. It would help in anti-tracking cube. As you can see, here's the structural smoothing. It looks more smooth and showing the signals much brighter. A chaos cube is a chaotic signal pattern contained within seismic data, is a measure of lack of organization in depth and azimuth estimate method. This chaos will show, as can you see here, it will show places like gas migration paths, fault bodies, and intrusions. But we use it as an input to create the anti-tracking. The anti-tracking is a vertical phenomenon developed by the ants capture information related to the fault zones in the volume. This will show the discontinuities of, as can you see here, they will lower the chaos view and show only the important discontinuities. It will remove the salt bodies, intrusions, and gas migrations, and it will be concentrated as in the discontinuities in the cube. Here, showing as an example of fault tree, we have 5 faults. This fault tree has been interpreted through the anti-tracking cube. As you can see here, this discontinuity is clear in dark black, and this in blue, yellow, showing the fault tree interpreted. The blue line is representing the member 5AB, and the yellow line representing the member 2. The fault here is interpreted into the window, so through seismic interpretation using the anti-tracking cube. And here, the fault tree is interpreted on the normal seismic cube. It shows the difference. Here is more clear. It will only show you the discontinuities where the fault were found. As in 3D, here's the fault in 3D. As can you see the discontinuity here? The red line showing there is discontinuity. Look. This process had led to discover 5 faults in our area, which is randomly named as fault 1, fault 2, fault 3, fault 5, and fault 4 and fault 5. Here is our major fault in the middle is fault 1, and here's the fault 3 that has been example in our show. Fault 2, fault 5, and fault 4. As can you see, the biggest fault in the middle of the cube, but the fault wasn't sufficient enough to create a pillar grading, which we'll discuss it later. The simulation fault created faults directly into a 3D grid. Instead of using a 3D model faults, we used simulation faults because the modeled fault only used in pillar grading. But this step won't be needed in simple grading. We use simple grading. So we had to create simulation faults. It will present faults, but it will identify the transmissibility of the faults as 0. So it will not, it will make the transmissibility 0, and it will limit or not making the fluids moving through these faults. The faults here will be represented as a barrier. That's all.